Good afternoon to all of you. And today I'm going to talk about the disease survey, surveillance, and the assessment. So, disease survey it is very important for reporting any kind of disease incidents in our area. As you know that you might have seen that the present situation, there are a lot of statistics which are going on during this pandemic. How many people are infected? How many people are after infection recovered in terms of percentage, in terms of deceased person? All these data can be generated. So it is data taken from the ground level. So in the same case, if you visit a garden or orchard or in the field where the crops are grown, we must take a survey of the presence and absence of the disease. So disease survey is a very important to take note of it, the occurrence of a disease, the onset of any kind of disease, and then that has to be reported. That is a surveillance. And prior to that, how to assess this. So in this class, I will be explaining all about in detail. Okay. So the first one is a survey. Survey on the plant disease it is one of the important aspects in the disease management. So prior to management, you must know how much percentage of disease is there. If it is 1% disease is there, can I go for a treatment? It is not advisable because it has not reached that economic damage level. Say, for example, out of 100 rupees, right? So your damage is only 1 rupee. The disease is causing the yield loss for 1 rupee. Need not to go, right? So because if you take that for the disease management, you may purchase a lot of inputs like pesticide or insecticide and other inputs, right? Say, for example, out of 100 rupees profit, to manage that disease, if you spend 5 rupees, okay, so the disease yield loss should be of more than that. If it is a 15 rupees yield loss, then you can invest 5 rupees. So to manage that or to gain the 15 rupees of loss. Okay, you got it? So the first is very important to take a decision to manage the disease or not. It is very important. That's what survey it is. Survey of a disease is playing a major role. It is useful to know the prevalence of the disease. Whether crops grown in different parts of northeastern states are quite different. In Arunachal, ginger, citrus, large cardamom, in high altitude kiwi and apple. So depending upon the place the crops are grown. Say for example in citrus, what are the diseases are common in here, which is so different from the citrus grown in Nagpur in Maharashtra. So to know the prevalence of the disease in a season in a crop of the particular area. So we must know record of it, right? So this is a citrus crop, and here this is a major problems. This citrus triticum virus is a major problem, whereas in other places some other diseases, right? So ginger soft rot is caused by fusarium is very common in Arunachal, whereas soft rot is caused by bacteria is very common in Sikkim. So a particular area the pathogen may be vary. And the second point is to correlate the disease incidence with the weather factor. Whether this weather factor, excess rainfall, will it contribute for the disease development? We must know it. Okay. And then biological factors and soil factors. That soil factors, say for example, acid soil or alkaline soil, will they favor for the pathogen for the contribution of a disease development? So these soil factors sometimes contribute for the disease development. Then biological factors, right? So all these factors we must know, right? Then third one is forecast the disease and inform about the outbreak of the disease of the crop growers. Now as we all know that when the pandemic of coronavirus, everybody asked to take a precaution and don't come out of the home, and you have to wear mask. So many restrictions, right? So it is forecasting the information has to reach to the people. Okay, so that is there's a prior information. The same way in crop also we must predict or we can forecast the disease incidence depending upon the weather factors which are developed on it, and then the outbreak of the disease. Okay, so that we can develop, right, using that some of the statistical analysis we can analyze, we can predict it. So these are the importance of the plant disease survey. Why it is very important to know the disease, to correlate with the other factors like weather, biological and soil factors, and then forecast. Okay, so these are the point we must remember. And then fourth one is to assess the damage caused by the disease. Say, for example, if you are getting 5 tons of yield, in that case, if it is of 300 or 400 kg of damage caused by the pathogen, it is more considerable. So to assess the damage out of 5 quintal, so 1 quintal if it is affected, so it is huge amount, right? 20% in 20% loss. Okay, so and the fifth point is to find out the occurrence of the new disease, like whether this disease are attacking the tomato and brinjal and chili, whether it is new. So we must able to understand that occurrence of the new disease. And then the other point is to work out the management practice, the control of the disease. So quickly we have to formulate some kind of practices to manage the disease. Okay. And then methods of survey. There are different kinds of method is there. So first we studied about the importance. The second thing is how to make a survey. So in a village, in a district, okay, so in a state level, right? So starting from village, block, and then district, and then state level, right? And the whole region, northeastern region, right? Okay, so before, it has to be done at the basic in the field level. In a village, you can choose 3 or 4 field, and then you can survey, right? There are 2 kinds of surveys there. One is fixed plot survey. The another one is roving survey. Let us see one by one. The first one is a fixed plot. Okay, so in that fixed plot, as I said to you, first one is the farmer's field, and then that village, and then block level, district level, and then state level, right? So in the villages, a minimum of you must take the 2 villages, right, in that division or the block level, right? And then select 2 villages and 2 fields of 1 acre to be fixed. So minimum 1 acre area you must fix in that area, and then you have to mark that area. The plant sampling should be 1 into 1 meter size. Okay, so fixed size you have to fix it. 1 meter area, 1 into 1 meter area. In that particular area, how many crops are there? Say for example, tomato, onion. So in brinjal, so how many crops are there that you have to fix it? In each plot, 20 representative plants of the leaves to be collected. If it is of a leaf, the 20 leaves has to be counted, and the plants means minimum of. So we must fix that. We must fix that. Choose that plant. Okay. So 20 representative, right? Okay. Then after that, we must do some grade. Okay. Let us see that grade and other things later part of the class. I will explain to you what is the grade we must employ to assess the diseases. Okay. So there are a number of diseases are there. The leaf rust, leaf blight, downy mildew, powdery mildew, and so on. So we will study one by one. So then one is a roving survey. That unit or block villages. In previous case, the 2 villages we have seen, and then then village and this area to 1 into 1, and then 20 sample. Here, this 4 representative villages for individual crops are selected. Say for example, if you are going to assess tomato, and then you have to take 4 villages. And in each village is 2 field. Okay, so 2 field once again, and observe 100 plants or the leaves, and you must score them. What is the percentage of disease incidence in a particular area, right? And that, to do that process, we have to walk across the start from south to west corner, right? And then north to east corner, you have to move in that way. And then finally, you have to assess the disease incidence, okay? So that is very important. And then after assessing disease incidence, we must send that report, okay? So surveillance report, right? Okay, how much percentage of disease incidents are occurred? If it's disease incidents, then we have to report it. It is not problematic. White. White means peace. Always, you know that peace, right? So, and then yellow. Yellow means alert, right? It means that it has to be sent when there is a disease first occurrence reach half of the economic threshold level. So what do you mean by economic threshold level? Economic threshold level, we can assess it. As I said to you, like damage by which that incur the loss. Okay, so your input cost for the management of the disease, if your input cost is very high, then there's loss, then we should not initiate any kind of management method. If you are this yield loss, if it is twice or thrice higher than that of cost of that your input management cost, then we must initiate for the disease management. Okay, so very simple principle. As I said, 100 rupees you are getting yield, 100 kg yield, right? So 100 rupees, say for example 100 rupees you are getting yield, in that out of which your pesticide or insecticide cost is 5 rupees, right? 5 rupees. But your your damage is only 2 rupees. So need not, because your input cost is 5 rupees. So to gain 2 rupees, why you want to invest 5 rupees, right? So then that is not economically damaged. Your yield loss also 5 rupees, and your input cost or purchase cost for the chemical is also 5 rupees. Then equal, need not initiate. Okay, so your yield loss is 10 rupees, and your management cost is then 5 rupees. Okay, so then you can start initiate. Okay, so it is just if it is reached half, then 5 rupees input cost and 5 rupees yield loss. That is a half of them. That it is equal. Then you have to be very alert, right? So then every beyond that economic damage level, then you have to start initiating this management method. So yellow card you should set alert. That is half of the level. When it is reached this threshold level, then we must give this yellow card, half of economic threshold level, right? So if it is 5 rupees, then 2.5 is half of that. Okay, so that is yellow card. Then when it is reached above, right? So economic damage level. If your damage level is more than that, then we must show this red card. It should be sent when the disease or occurrence exceeding economic threshold level. Simultaneously, it has to be this economic you must start advising this management methods in a particular area, right? Okay. Now, to do that, the first thing is assessment of plant disease. Actually, after assessment only you have to give the report part that I have talked about, the surveillance. The report part that we call them as surveillance. Then this assessment has to be done prior to that, right? So the first assessment factor is how to do the assessment, right? So we must take some note before going for this survey. Growth stage of the plant. What is the stage? And then study the course of the disease, right? Which course it is, initial stage or this mate or greater, that you must know that the stage, okay, course of the disease. And then standard diagram for the assessment of the disease survey. You must prepare this standard diagram. Okay, so I will explain you how to do that. And then observation of the disease with the diagrams and the yield of the crop. Okay, so you must predict the disease you must know this disease incidence and the yield, expected yield. Okay, so that we can easily assess this yield estimation, right? So for using this regression equation, so y equal to a plus bx, that is y is a dependent variable, and that is the yield is depend on the input, the fertilizer, and other parameters. So we can easily calculate that yield of that particular crop, and then so that disease incidence is this much, so this much yield loss is going to occur, right? So that we can also this assess the disease incidence using that formula, right? The same y equal to, you can forecast or predict, okay, using this formula y equal to a plus bx, where these different parameters x1 a plus bx, that b1 x1, b2 x2, b3 x3, and so on. So if you put all these variables like minimum temperature, maximum temperature, relative humidity, that is all these independent variable, if you put everything together, then we can predict. Okay, to get to the constant, you should have at least 5 or 10 years of data. Based on that, we can predict the disease incidence, right? Okay, and then calibration of the disease severity with the crop loss. That's what calibration you can done with that formula. Okay, so remember that formula, y equal to a plus bx. Okay, with that formula we can work out. Okay, now the first one is disease assessment. The first one is the disease assessment. It can be done this some of the diseases which are affecting the whole plant. That is, first one is virus. Virus is systemic. So once if it is enter into the plant, the whole plant is get infected. So we will take account of the entire plant is being infected. Say for example, in 100 plants is there, only 5 are infected, then we say 5 of them infected, right? So that's what in viral and phytoplasmal disease. It is also systemic, right? And then damming off, which completely destroy the plant, the single seedling. So that damming off. The another one is vascular wilt in many of the trees, and even this fusarial wilt, and so on. And then root rot of different crops that we can analyze, right? So put into that all the data into that formula, that is a PDI, percent disease incidence, PDI, that we can easily calculate using that formula. Number of the diseased plants divided by total number of the plants into 100. Say for example, it is very simple. In a village, 5,000 people are there. Out of 5,000 people, 500 people are COVID infected. Then 500 divided by 500 divided by 5,000 multiplication with 100. Okay, so that we can easily assess it, right? The same way here also, it is very simple. If it is out of 100 plants, 10 are infected, then that is 10%, right? If out of 100, if it is of 25 plants are infected, then 25 divided by 100 multiplication with 100, then it gives 25%. I'll show you some good example now. Here you can see. Now this is a cabbage field in our farm, in our college farm. Now by visualizing, you can see now. You see, you can easily assess it. Okay, how many these cabbage plants are there? In between, these plants are not there. That is wilted. Okay, so you can see 1, 2, 3, right? Here also 4, 5, right? 4 wilted plants are there, right? And that is wilt. Okay, so this wilt is 4 out of you can count the total number of cabbage, and then you can say that 1, 2, 3, 4 are wilted. Now, and interestingly, some of the plants are healthy, and some of them is showing this cauliflower mosaic virus. You can see here in between, some of them, these leaves are, this is showing this curling, puckering symptom and crinkling. That is a viral disease, right? Cauliflower mosaic virus. So that we can easily assess that these are, out of this, how many plants, this many plants are being infected with cauliflower mosaic virus. So in a single plot, you can easily assess it, right? So plant disease assessment, like now, you see that it is most of this, this cabbage field, you can see this cauliflower mosaic is being infected. So you can predict it. Now, more than 25% of in this field, infected with cauliflower mosaic virus, we can say to the farmer, be alert, this cauliflower, more than this wilt disease, the cauliflower mosaic virus is going to, become very serious this year. Then you won't be getting any marketable head. Okay, if cauliflower mosaic virus infecting, then you won't get any cabbage at all, marketable head. Okay, so we won't get it. So that part here, by taking even picture, we can easily analyze the incidence. Okay, it is very simple. You got the point? Now, I'll show this next plant here also. You see this brinjal plot in our farm. And now see, soon after transplanting, and after transplanting, transplant shock will be there. But then in spite of that, some of them being infected with the wilt disease. You see, you can count this brinjal plant, and then few of the plants are not there. It is being infected with the wilt disease, right? Fusarial wilt. And then you can see that this, you can easily count them. And then, out of this, how many brinjal plants? 1, 2, 3, 4, 5, and 6. Okay, so 6 plants are infected, right? So you can easily calculate this incidence, right? So this formula is applicable for certain kind of disease only, right? One is viral disease, phytoplasmal disease, and then it will apply for the wilt disease, rot disease, and then this vascular wilt disease, and so on. Okay, so this formula, it is not applicable for the disease which are attack on leaf or the foliage. Remember that. Okay, so but if you see that cabbage cauliflower virus, though not done, in previous case we have seen, now you can see here, this is virus only infected, but we can set account of whole plant is get infected. Okay, so that's what we see here, right? So this is what I want to show. Though the plant is alive, then we will take account of this is totally infected. Okay, so let us I'll show some example. Okay, now you got this brinjal. You can easily count by taking this picture, and you can easily assess them, right? Okay. Yeah, okay. Okay, now you can see this citrus garden in Arunachal Pradesh. This is the citrus garden in Arunachal Hill, and you can see here. Yeah, there was a network issues. Sorry for that. So Okay, now you can see this is ginger in our college farm. You can see this, this incidents. You can see, you can easily examine. So here, most of the ginger crops are very healthy. Okay, so that's what here you can easily observe it. And most of the, ginger plants are very healthy, right? So, but then a few, one or two were infected. In between, you can see this ginger rhizome rot. Okay, so you can easily assess that disease incidence, right? So it is very simple. Disease assessment is very simple. Okay, and then the next one is citrus garden here in Arunachal Hill, and you can see here you can easily recognize there was a citrus greening, right? So easily you can assess this plants is showing, yellowing, and this started showing this wilting symptom, right? Okay, so it's yellowing and then gradually decline, right? So this is citrus greening. So out of this, if it is 20 trees, out of 20 trees, 1 or 2 is getting infected, then we can easily assess that, out of 20, if it is 2 infected, then we can easily, okay, 2 divided by 20, right? So it is very simple. So we can assess in this way, right? Okay. So the next one is assessment using the disease grade. Here comes, it's very important for assessing the diseases which are occur on the leaf. So we call them as leaf spot, leaf blight, blast, ergot, powdery mildew, downy mildew, right? And then rust, canker, all these diseases, we call them as to assess that disease using the grade. Okay, so the grade is very simple. I'll show this next slide. So for leaf spot, blight, and anthracnose and blast. Okay, so draw the leaf structure. So same this typical leaf you can draw. Say for example, tomato means draw the tomato leaf and put it no disease 0. And then 1 means grade 1 means less than 1% of area infected. So you can assess visually, or you can use that leaf area assessment, leaf area assess meter. You can use that instrument to assess the leaf area. So if a green area, and then if it is definitely infected, the color of the leaf will be changed, right? Whether it may be brown color or like black color, or sometimes green color, or sometimes it may be of white color, right? So that we can easily assess them, right? Okay, so now you can see this grade 3, 1 to 10% area is affected. Grade 5, 11 to 25%, and 7, 26 to 50% leaf area affected. Likewise, you can easily, put this grade, right? After making this grade, so say for example, downy mildew, powdery mildew, and sooty mold. Powdery mildew, it is widely infecting, many of the crops, even vegetables and the fruits, and then downy mildew on the grapes, and then sooty mold you can observe it on guava, and then sapota, and then kasi mandarin, and so on. Now grade on the left, you give some grade 0. 0 means no symptom. 1 means less than 1% of leaf area of mildew growth. Okay, so you have to draw and then compare in the field, right? After assessing, putting this grade. Okay, so coming to next. So this one is for rust. Again, this is same. This less than 1%, 1 to 10, 11 to 25, 26 to 50, more than 50 is grade 9. Now, so the first thing is go to the field and look at the leaf. Like before going there, you can make this grade and compare the grade with this. See for how many percentage of, if 50% of leaf area is infected or less than 50, 45, then you put this grade. Like, okay, so go to the field, mark at least 10 plants, 10 or 20 plants. Like out of 10 plants, assess the leaf, right? So if it is 10% leaf area infected, plant number 1, grade is 3. Plant number 2, assess the grade. If it is of no symptom, then put 0. Plant number 3, if it is infected with 5%, then grade 3, right? And then if it is another plant number 4, if it is infected only 15%, then grade 5. Okay, then we are not gone up to 9. So remember that 0 to 5 grade only I have given in my field, because it has no incidence. I have not assigned the grade 7 and 9 because that much incidence is not there, severity is not there, right? Okay, now, so note that grade, okay, maximum grade used in that particular assessment. Now, I'll show this table. Now, you see that I have assessed this, taken the 10 plants, and then I have given the severity grade. Plan number 1, 9, plan number 2, 9, and then plan number 3, 3, 4, 1, 5, 9, 6, 3, 7, 5, 8, 7, 9, 9, 10, 1. And then you have to, after, this, how many leaves you have assessed, and then you have given the grade, okay? So this again, 20, right? This 20 plants here we have taken, and then severity grade as given, right? So now the thing is, number of plants is 20, and the total grade is 88. Okay, so it is very simple. Total number of plants and the grade you must note, and then put into that formula. Now this is the final formula. Percent disease incidence, PDI. It is a very simple formula. Sum of individual rating, right? Remember, sum of individual rating, that is 88. So individual plants, all these individual plants, after assessment, sum of it, okay? So make a total, sum of a total rating divided by total number of plants or leaves observed. 20 plants are assessed, okay, 20. Multiplication with 100. So we are converting in terms of percentage. So we are multiplying with 100 and divided by maximum grade is used. So maximum grade is used here is 9. So if it is limit only 7, then you can give the 7 number, right? So you can give accordingly, right? Okay. So now, so maximum grade, it has been given 9. Now we can say that it is a 48.89%. Okay. So it is very simple. In this way, we can calculate. Right? So that's all about this plant disease assessment. Okay. So if you have any queries and questions, you can ask me.